Hey folks, hope everyone's doing well. Happy Friday. My name is Spencer and I'm an engineer at Talos. I wanted to spend a little time today talking about Sidero, right? And so Sidero is our bare metal management platform for Talos and Kubernetes. It's built on top of Cluster API, and we've had some pretty great interest in it actually, and that's been really nice to see folks wanting to do bare metal Kubernetes. One of the things we have seen though, as we talk to people, is people are wanting to try it out kind of without committing to providing a bunch of bare metal for it right away, which is totally reasonable, and they've been wanting to check this out on VMs. So we've not had a great story for that historically, or at least so far. So I spent a little time this week playing with this in Virtualbox and trying to do a full Sidero stack there. So I wanted to show that off, and this will be a little longer form video because I'm going to walk through the entire process of setting up a Sidero management plane and then creating a workload cluster out of that management plane. But it should cover a whole bunch of Sidero stuff, and we should learn a lot, hopefully. So yeah, it's all good stuff. Let's spend a little time here. Let's go ahead and share my screen, and the first thing you'll want to do is probably head out to sidero.dev. That's our docs page for Sidero. You'll also want to go to the V03 release of this. That's going to be your latest docs, as well as some of the changes and little bugs that we fixed are probably covered in here as well. And things are just a little easier to use in V03. The other thing you'll want to do, of course, you guys are probably sick of hearing me say this, but you'll head out to Talos, the Talos GitHub releases page, and the 0.10.2 release. We will go ahead and scoop up the Talos Iso, the AMD 64 Iso. I've already downloaded it, so I'm going to skip that. And you'll also want to scoop up the Talos CTL for your environment. So go ahead and grab those two things. And then you'll be ready to roll. So first things first, let's go ahead and create a Sidero management plane. So this is our kind of single point from which all of the workload nodes, all of the workload servers will pixie boot off of. It's also what we'll talk to when we want to go create a Kubernetes cluster with Cluster API. And so let's go ahead and get that management plane online. And to do that, we're going to use the ISO to bootstrap it. So we'll say new here. We'll give it a name of Talos Management. Tweak a few little values. I'm going to give this 2 gigs of RAM. And that should be fine. 8 gigs of disk should be plenty. Let's head into the settings after we've created that, and we'll do a couple of other things. The first thing we'll do is we'll give it a second CPU, and we'll also, in the network settings, we'll change this to a bridged adapter that uses my Ethernet device. And we'll do that so that it comes up on my home network, and I can use my home router as my DHCP server for all this stuff. And I'll go through configuring that as well. So we'll do that. 2 processors. The only other thing, actually, yeah, that should be fine. The optical disk is there. What else? Storage. Okay, so we'll also go and grab our ISO file, and we will open that up, and we'll say that's where we want to boot from. So we'll say OK there, and we'll start this bad boy up. Cancel that. Scale mode so we can see some things. And what this will do is it will boot. You've probably seen this before. I've made a couple videos of installing Talos this way, but this will boot into maintenance mode, and then we can configure it using the interactive installer to get it all online. So we'll wait on this, and then this is kind of what we're looking for, right? Where it says you can upload a configuration using this thing. And so we'll take note of that IP address, and we'll say Talos CTL apply dash. Let me get into my little VBox demo repo or directory so that we're all clean. Talos CTL apply dash config. Let me blow that up just a touch. People were saying last time that they couldn't see that well. And we will give it a -n for node, 192.168.1.94, I believe. Let me go double check that. Yes, -- interactive, -- insecure. And what this will do is this will start up our TUI installer. And so this will give us our install image. This is a disk we'll install to. That's all good stuff. Machine type control plane, fine as well. I will give this a cluster name of Talos management, and then I will allow scheduling on masters. Host name as well. I will change to Talos management, and then I'm going to leave the CNI the same. That's all fine. And then we'll say install. And so what that will do is in the background, you should see this guy installing, which is great. It's pulling down the installer image from GitHub's container registry, and it's all installed and rebooting now. This will take another couple of minutes probably to get everything online and get access to, to actually get access to Kubernetes. So we can wait on that. It should be fairly quick, but it does take a minute or two, especially with 2 gigs of RAM and 2 CPU. But let's walk through this. I'll talk through what's going on. Looks like we're bringing up networking and the API D, which is our all of our APIs for Talos. And so once that goes running, we will be able to talk to it. So the interactive mode of apply config actually goes ahead and dumps out our Talos config. So I actually had an environment variable set to the local directory, so that's where I dumped it out, which is fine. But what I will do now is say talos-ctl dmessage -f and then -n as well with that IP address. So again, we can see all of the same dmessage output that you're seeing on the left. Inside of the console is here via the API as well. And so I can also now do kubeconfig. So I'll go ahead and say kubeconfig against that node, and it says, hey, you've already got a kubeconfig in your kubeconfig. You've already got a cluster for this. Do you want to overwrite it? And I'll say yes. Same goes for the context. And then once it does that, it's automatically configured to talk to that Kubernetes cluster. So let's see if it's up yet. It's up, but their node has not registered yet. So we're waiting on the kubelet to register itself. There it goes. It's not ready, but we're getting there. Let's get some pods and see what's going on. We'll watch this as well. It shouldn't take, more than another minute or so here for everything to come online. It's pretty quick once things get moving, and we should be in business. One thing that I am going to do is I'm also going to double check that I have removed the no schedule taint on my master node, or on this this one control plane node, just because it's the only one in the environment. I know we ticked that box in the interactive installer, but I just want to make sure that it got removed. And so I will do that. I've got that documented. That's documented here in the bootstrapping guide. So I'm actually just going to go scoop that up and edit it for my environment. And that's just going to be a kubectl taint node. And then the node is Talos management. So, and then again, getting some pods, core DNS coming up. Cool. Almost there. And then we'll be able to go ahead and install Sidero. And so Sidero itself is really just a cluster API infrastructure provider. And then we make use of the other parts of cluster API that we've also written. So the control plane provider for Talos and the bootstrap provider for Talos. So we are going to deploy all of those things in one fell swoop. And I'll show you how to do that. But the first thing I'm going to do is take note of the IP address of this guy. And that was the 192.168.1.94. And I'm going to export that as an environment variable. public IP equals 192.168.1.94. And so now that I've got that as an environment variable, I am going to grab this monster and I will walk you through what's going on. But we're going to use the cluster API tool called clusterctl to initialize all this stuff. And as part of that, we're going to set some environment variables beforehand that we're going to use as part of kind of initializing this thing. So we're going to bring our metadata server up on port 9091, and it's going to be on host network, so we can hit it immediately. We don't have to mess around with metal-LB or node ports or any of that stuff. Same goes for the controller manager, which is responsible for the actual server resources and checking them in and allocating them to clusters and all that good stuff. So we're gonna export these environment variables, or not export them, but we're gonna use them for this initialize command, and we will just fire this bad boy off. What that's gonna do is install cert manager, then it will install all of the cluster API components, and everything will just kind of come online and be ready to roll. And again, that shouldn't take more than just a few seconds here, waiting on pods or images to get pulled and pods to start up. So should be pretty quick. One more. Two more, actually. Worth pointing out, because I forgot it a second ago, though, is that when you do clusterctl init, the -i flag is for the infrastructure provider, -b is bootstrap, and -c is control plane providers. So you'll want to provide all of these in setting this up, and you'll also want to make sure that for the infrastructure provider using the alpha 0 release of Sidero, the 0.3 alpha 0, because again, that contains a bunch of fixes that I had to do to make all this stuff work, and make sure that we could schedule it on, get all these pods scheduled on a Virtualbox kind of smaller VM. So make sure you're using the alpha, and then, or at least something from the V03 series, if you're doing this a little later on. But for now, the alpha is the only thing out. So we'll initialize that way, and then we can get some pods. And so it looks like everything's up and running, and that's great. One good way to kind of test some of this stuff is to double check that the metadata server is online. So if I do a curl of 192.168, 1.94, we're doing it port 9091, and that'll give me a 404, just because that's kind of the default for the web server. But if I hit config data, I can see like, oh, I got a metadata request, but I didn't give it a UID. So that's just to kind of confirm it looks like it's working is all, really, just to confirm that things are up and working. Similar story on port 8081, and that's going to be our server for all of our iPixie stuff. So if I do, if I do iPixie, I can see here's my iPixie script and all the things that boot our agent environment. So everything's up and working. That's great. Management plane's ready to roll. So let's go and configure a Dhcp server. So if I go into my edge router, admin at 1.1, give it a password. And then I'm going to become... Actually, I'm not going to become a super user yet. Let's double check some of this stuff that's in the docs. So I wanted to show you guys what I have set up for this. Actually, this is what I have set up for this, so I won't bother. But if you go and show, if I go and show my DHCP server for this network, I can see the important bit for me, at least, is that inside of the subnet, I've got the subnet parameter section. And as part of that, I'm including a secondary comp file. And that's what I'm going to go edit here. But just to kind of take note that I'm doing that by getting the subnet parameters and including this extra file. And so now I will become a super user. And then I'll go to etcdhcp. And then I've got this ipixiemetal.conf file that you just kind of saw me reference in that subnet parameters. And then if I want to open that in VI, I've got a bunch of stuff that we no longer need, which is awesome. So now it's pretty slick. I will point to the next server, which is my management plane, 94. And then I will say file name of this UNDI only. And so it'll either be this or it'll be ipixie.efi, depending on how you're booting. And the network booting for Virtualbox is BIOS, like kind of legacy BIOS mode. So we'll use this UNDI only file name. And that should be all I need now. It's actually significantly less complex than it was. You saw that all those if-else statements that I had. Shouldn't need all those anymore, which is really nice. You just need to point to the next server and give it a file name. So we'll say UNDI only.kpixie. Next server is 94, which is that IP address of the management node, of the management plane. So I'll write that out, and then I will do a sudo system, well, I'll do a systemctl and restart. And on the edge router, this is Viata DHCPD, but restart your DHCP service. Cool, ready to roll. And now we're ready to add some servers here. So let's see. Let's check the docs and make sure that's true. Yeah, I think we're ready. So let me pull up VirtualBox and we'll add a new VM. And we'll call this bad boy Talos 0. Again, kind of tweaking these things. And then I'm going to actually just go ahead and create this. And then I'm going to edit it after the fact with VBox manage. I didn't do that for the first one because I was too lazy to look up how to boot or mount the ISO. But I know how to do the rest of this stuff with VBox manage. So I can say something like VBox manage modify VM, give it the VM name of Talos-0, and then I can do kind of all of these modifications I want to do in one foul swoop. So CPUs of 2, memory of 2 gigs, 2048, and then here's a couple of the more interesting little bits that I'm going to do. The first one is going to be NIC1, saying the first NIC is actually going to be a bridged NIC, as opposed to the NAT default. And then I'm also going to say bridged adapter 1. And then I'm going to point that to my actual Ethernet device, which is EMP37S0, which is super easy to remember. And then finally, I'm going to tell it that I want it to PXE boot. So -- boot 1. And this is, first in the boot order is going to be net. And that should be all I need. Is it bridge, not bridged? So cool. That should be ready to roll. So now you can see that stuff's kind of updated. This will now come up on this bridge, on the on my subnet, on my home subnet. It will hit the DHCP server and it will PXE boot against the management plane that we've created. So cool stuff. Let's do VBox manage start VM of Talos-0. And one thing kind of to point out is Sidero is built with a bunch of IPMI stuff in mind, really, and having access to actually turn things on and off and all that fun stuff. You don't have access to any of that in VirtualBox, so we're going to do a lot of turning off and turning on of this VM, which is just kind of the nature of the beast. But I did see kind of funky issues with doing a reset in VirtualBox, like a restart, versus doing a full power off and power on. So that might be something else you want to kind of keep in the back of your mind, that you probably want to do a full power off and then turn it back on to make sure that things kind of boot up correctly. So what you saw happen just now on the left was it booted the agent image, which goes and collects a bunch of SMBIOS information and tries to detect if you have IPMI on the local box, and if so, it will set up a Sidero user. But again, and then it will register into the management plane with all of that info. So now I can do a kubectl get servers. And I can see that I've got a new server that just registered. It hasn't been accepted yet, which is important. But it just checked in and gave me some info about it. So if I do a -o YAML, I can see all of that info. So I can see kind of what we were able to deduce with SMBIOS information, which is probably not much because of, hey, VirtualBox. But I could see this is a VirtualBox virtual machine. We've got a host name of an IP address, and then an unknown CPU and version. So not crazy helpful, but it is enough to say like, hey, this is a VirtualBox VM. So the next thing I'm going to do is I'm going to say kubectl edit server. And I'm going to head down into here, into the spec, and I'm going to change this accepted value to true. If you look in the Sidero docs, there's a patch command for this too, a kubectl patch that makes it a little easier, but, whatever. So save that back. That server has now been accepted into the environment. Unless you do that, we won't do anything to this box. We will basically just return a no op if it pixie boots against the management plane. We'll just say like, hey man, we know about you, which is great, but we don't, you're not accepted, whatever. So anyway, we won't take any hard actions. But now that I have accepted it, I can do something like vbox manage. What is it? Not modify VM. Let's see, control VM. So, I'm still working through learning the vbox manage commands, but vbox manage control VM and the VM name, and then say power off. And that will turn that machine off, and then you can start VM to bring it back online. So once it does this, it will boot into the agent again. But when it makes the request to the management plane will say, hey, yeah, like I already know about you, and you also need to clean yourself up and get ready to be part of a Kubernetes cluster. So what you'll see happen on the left is a bunch of output around wiping disks. So it goes ahead and wipes dev SDA and then goes into a reboot. And so let me go ahead and power that off again, which is great. It's all good. It's now wiped and ready for allocation in a Kubernetes cluster. So it's part of the server pool. So now if I get servers, you'll see that it's accepted and it's clean. So it says that, yeah, it knows about this thing. It's ready to roll. And so now we're ready to kind of get ready to boot a Kubernetes cluster. So let's head to the docs again. We've registered and accepted the servers. This is important. So we'll want to create a default environment. And so this environment is things that, kernel args and things like that tell Talos how to, configure itself when it comes online. So these are all all this stuff kind of gets mixed and mashed together to create the machine config for the Talos node when it comes online. So again, you'll notice this public IP that I mentioned earlier. That's just saying, hey, here's the metadata endpoint for your Talos config. And then here's basically the links to the latest release of the Linux kernel and our net. And so let's go ahead and inject this bad boy into our environment. So it's just a cat EOF. And again, that'll use the latest published Talos release, which is that 0.10.2. And so that creates our Sidero environment. The next step will be us getting ready for our management, or our not our management plane, our workload cluster. So this is pretty interesting. Again, we're doing some, just some variable substitution and things like that. But I do want to, before I go and do that, I want to create a server class. And so a server class says, it's basically a way to pull the servers together. So if I do a kubectl get server class, you'll see that we have an any server class, which is great, but I actually need to specify what's called a config patch. And so a config patch is something that says, if you use Talos and not Sidero, you may already be familiar with this, but it's essentially something that says, it's kind of like customized, and it says, for the machine config in Talos, I want you to update kind of this value in the YAML, right? So anyway, we'll go ahead and create a server class called vbox, and we will kind of get that rolling. But I'm not going to swear that I could do that on my own, so I'm going to actually grab this one. Actually, I'm not going to grab that one. I'm going to grab one out of here because that'll be a better example or a better starting place. So in my VBox demo directory, I will blow this up a little bit so folks can see. That's maybe a little much. So I'm going to create a server class called VBox, and I'm going to specify some qualifiers for it. And so qualifiers are just ways to say, it's kind of like a label selector in Kubernetes if you've dealt with those. But I can say, as we looked at our servers earlier, the best way we could come up with to qualify is probably on the system info, right? So we say all of the Virtualbox system info, or all the virtual machines, is kind of what we want to filter on. So what we'll do is we will say qualifiers of system info, and then I'm going to just paste this guy. I don't care that much about the serial number, so I'm going to go ahead and drop that that selector. But I will say that we want product names of VirtualBox and SKU numbers of virtual machines. And I'm going to call that vbox-sc.yaml. And that should be hopefully it. Let's make sure I got that right. It should be under system info. Yeah, okay. So that should be right. Keep in mind that these are kind of logical ands at this top level key and logical ors as part of CPUs. So like in this example, it would select either of these CPUs, but it would also have to have this my server label, right? So just keep that in mind if you're messing around with these guys. The thing that I do want to do though is as part of the spec, I want to make a config patch. And I'm going to, again, cheat a little bit and look at the patching guide and pretty much steal this guy, I think. Yeah, so I'm going to steal this config patch that says our installed device is going to be dev SCA because that is actually the correct value for VirtualBox. And so I will add that as a config patch to the server class. So anything that matches this server class, when it gets allocated to a cluster and it goes to fetch its metadata, this config patch will get, again, mixed in, and it will become part of the metadata. So what I'll do now is kubectl apply vbox sc. Oh, system info is not the right thing. Let me go look. I would do that by going to cluster. I'll go to Sidero, actually. So in the Sidero code, I will then look for server class types, and it's system information, not system info. So let me update that. And then I'll apply it finally, hopefully. Yep, cool. So if we look at the server classes, oh, good grief. I can now see that there's two server classes and they both show the same available server, which is fine because they both match that server class. And so that's just a point that you can have multiple server classes, that a server can match multiple server classes and can be used as part of a bunch of different pools, which is really nice. And it won't be allocated to two different ones. We handle all the binding of that and all that good stuff as well. So anyway, now we have a server class, and so now we're ready to go ahead and create a cluster manifest. So let's go back to the bootstrapping guide, and this isn't exactly the command we'll use, but I'll show you what we got. So this is pretty close to it, and I'm going to scoop this up, and we'll edit these variables before we kind of do this. But I apparently can't copy and paste. anyway, we'll select a server class of VBox for our control planes. Same goes for our workers. We'll give it a Kubernetes version, control plane port, and a control plane endpoint. We don't actually know that yet. Yes, we do. We totally know that because the server has already been registered. So let's go look it up. So in this server, it is actually 192.168.1.78. So we will give that as our control plane endpoint. So that's going to be, it's our only node. So it's going to be our master node. And then we'll export those things and we'll do a clusterctl command to generate a cluster manifest. So we'll call this Talos workload infrastructure provider of Sidero. And we'll give it a Talos workload.yaml. And so let's go ahead and throw that into our terminal. And we're missing Talos version. So one more. Export Talos version. And this is the version 0.10 release series. So we'll go ahead and do that. There we go. So now we've got a Talos workload YAML that we've created. And so there's a lot going on here. Don't get too worked up about it. What it's going to do is essentially say, here's some server classes, here's the things I want you to match against when selecting machines and all that good stuff. So the default way this will work is it will be a single replica control plane. Again, you can scale this up after the fact, which is really cool. And a 0 replica machine deployment. And so no workers, single control plane node, single control plane node, and that's pretty much all we'll roll with. So that should be everything you need. And then what we can do is we can do a kubectl apply and give it Talos workload.yaml. So that will go ahead and create the cluster resources and all that good stuff. Sorry, just a sec. So that'll go ahead and create all the resources necessary. And what it will do is it will allocate one of the servers that are in the server pool that you told it to use, the server class that you told it to use. So now if I do a kubectl get server classes, you can now see that one server is now marked as in use. And if I do a kubectl get machines, I can see that a control plane machine has been created. Machines are cluster API resource, but machines have been created and an underlying server has been kind of bound with that. So they're kind of bound together. And so if I wanted to check this out, I can actually, I mentioned earlier curling the metadata, and I can actually see what metadata this will get by doing config data and then UUID as a param. And so I can see the full-on Talos config, machine config that will come out of there. And I can even see that the config patch that I wanted of the install disk is now there as well. So that's all good. And I think we're ready to roll. So once that's created, I shouldn't have to do anything more now than power this bad boy on. And it will come up and it will do its thing. So what I will do is start VM of Talos 0. And it should pixie boot, get its metadata, install Talos, and then we'll shut it down and kind of swap the boot orders real quick. Because otherwise it'll try to pixie boot again, and it doesn't seem to handle that very well. And I think that's a Virtualbox thing because it works just fine on normal hardware. So it validated its config. It's pulling down an installer, installing to disk, and it's now done. So we will power that thing off with Control VM again, and now we will update. Good grief! Let's see. My notes are now huge over here on the left. or on the right. So we'll modify the VM. And so similar to the command we did earlier, we'll just change boot 1 though. And we'll say that we want to boot from disk because now Talos is installed. So let's power it on again. And Talos should come up and do its thing. Let's make sure everything looks good. Yeah, it's coming online. Okay, cool. And so what we'll do is we will go and fetch our Talos config for this node. So again, in the guides, there's a kubectl get Talos config command that I'll edit in place. And then we will drop that bad boy in here too. So there's a get Talos config. My cluster name is Talos workload. And I'm gonna say this is Talos workload, Talos config. So once I do that, I should be able to fetch that right out of the management cluster because it all gets generated there and pushed in as a machine config. So now I've got a Talos workload, Talos config. Cool. And what I'll do is I'll export my Talos config environment variable to match this new one, Talos config workload, Talos config. And then I'll do talosctl config endpoint, and I will give it that IP address of this management node. And I know that, but I've already forgotten it. So let me go look it up. I know we had it in here. 1.78. So let me do that. 78. So I'll do a config endpoint and a config node, and that's just configuring this Talos config file. And I'll show you that. So yeah, so it just sets this endpoints and nodes section, which makes it just really easy to use talosctl to talk to it. Caps lock on. Talosctl dmessage should give us some output. So yeah, I can see now that that node is coming up and it's been labeled as a master and it's doing its whole Kubernetes thing, which is awesome. And so that also means that I can do a talosctl kubeconfig. And that set up my Kubernetes context. So if I do kubectl config get contexts, you'll see that I have tons of them probably. But I do have a Talos workload context now, and I can do a kubectl get nodes. And we'll see if it's up yet. Yeah, it's up. Hasn't quite finished registering yet and doing all of its good stuff, but that Kubernetes cluster has been created. And so what's really cool about this is if I wanted to add a worker, it's really the same process, right? So it would be essentially, coming in, creating a new VM, registering it with, net booting it so that it registers with the management plane. And then it would show up in, let me switch my context back, kubectl config, use context. It would show up and get servers, and would show up in server classes as well. It would show up in servers first. I would have to accept it, boot it one more time, which would wipe it, and get it ready for consumption. And then I can even, at that point, then I can do something like kubectl scale. Let's see, kubectl get machine deployments. And then I can do kubectl scale machine deployments. Give it this workers, and then replicas of 1, right? So if I wanted to add a single worker, I would just do that. And that would allocate that second server because it would be the only one available. I can't spell deployments. And then it would... again, net boot it one more time, and it would come and install Talos, and then you boot it from disk, and it would join as a worker. Again, same process as creating the initial control plane node, at least as far as the Virtualbox kind of stuff goes. So that's pretty much it. That's how you go about trying out Sidero and Virtualbox. You can create as many or as few VMs as you want. and just follow that process for registering them, and then they're ready for consumption by the clusters. So I hope this helps, and I hope that folks try out Sidero. And if you need help, come hit me up on Slack. I'm happy to talk to you about it, and we will work through it together. So that's it for today, I think. I hope everyone has a good weekend, and hope everyone checks it out. Thanks.